Right, here's your brief summary of the electrolysis of aluminium for the C4 topic. Traditionally, we can use substances to displace substances in chemical reactions. So, for example, if you wanted to extract, say, copper from oxygen in copper ore, then what you can do is pick something that is more reactive from the reactivity series. And traditionally, we'll use things like carbon. It's cheap, it's readily available, there's loads of it around. And if we heat up copper oxide with carbon, the carbon is more reactive, so it's going to displace the copper, react with the oxygen to form carbon dioxide, and leave the copper on its own. And you get copper metal, which you can then use for whatever purpose you like. So we get this displacement reaction happening. However, sometimes though, the metal that you want to extract from your ore, which is the rock that these metals are found in, sometimes the metal is more reactive than carbon, so it won't work. This process wouldn't happen. You might think, well, let's just use something that's more reactive than aluminium. The problem is, though, is that you're going to then start using metals that are quite difficult to work with because they're reactive, they're quite hard to get hold of themselves, and the process is going to be quite expensive. So we need to find an alternative method to a displacement reaction because carbon's not going to work for us. So instead what we do is we use the process of electrolysis. Now, before we start looking at the process of electrolysis, we just need to have a little bit of an idea about what the actual ore is like for aluminium. So it's called bauxite, that's a U, it's called bauxite, and bauxite contains aluminium oxide. Now, if you add this substance called cryolite, what happens there is that the melting point of bauxite with cryolite is lower, and therefore you don't have to heat it up as much, saves your energy bills, and it makes the process cheaper. So what we're going to do is take bauxite, which contains aluminium oxide, add some cryolite to it, and then we're going to melt it down, and all the ions that are normally in fixed positions can now start moving around. So we get this molten ionic compound. Once we've got that, we can then do electrolysis. So here's how it works. Talk you through it step by step. We've got all in here, we've got our aluminium and we've got our oxide ions in there. What happens is when we put our electrodes in and turn the switch on, remember it's a DC supply that we use, we get an anode and we get a cathode forming. The aluminium ions, because they're positive, will be attracted to the negative cathode, and when they get there, they're going to pick up 3 electrons each because it's got a 3 plus charge. So those 3 electrons combine with the aluminium and it turns it into aluminium atoms. This is called reduction. And then the aluminium atoms will then sink to the bottom, and you'll get aluminium, liquid aluminium, forming at the bottom of your container. And once the process is finished, you can just collect that and then do whatever you want with it. The oxygen, on the other hand, goes to the anode, and when it arrives, each of these oxide ions has got 2 extra electrons that they don't want. Well, they do want them, but they're going to get rid of them. And what happens is they are passed into the electrode. When they go into there, they can pass around the circuit to the other side, and that completes the circuit. But then what you're left with is 2 oxygen atoms, which are unstable. So what they do is they pair up and form an oxygen molecule, and we get oxygen gas. We get bubbles of oxygen gas occurring in the reaction. However, because the electrodes are made from carbon, sometimes the oxygen reacts with the carbon that these are made from, and it forms CO2 as well. And when that happens, the carbon electrodes start to wear away and we have to replace them. So that's something that we need to bear in mind. Now, instead of writing all of this out and drawing a diagram, we could represent the whole thing just by using a couple of equations. So if you remember, the aluminium picked up 3 electrons and turned into an aluminium atom. The aluminium picked up 3 electrons, aluminium atom, so we can represent that by writing an equation out. And this is called a half equation, where we just write what happens using with the electrons to one part of the compound. On the other side, we had our 2 oxide ions. There they are, 2 oxide ions, and each one of them gave 2 electrons each. So that's 4 in total. So that means they lost 4 electrons as both of these together. The result then is that they then combine together to form an oxygen molecule, and this completes our half equation for this part of the reaction. If you put the 2 whole things together and get rid of what happens with all of the electrons, we're simply left with the idea that the aluminium and the oxide then form aluminium metal, and oxygen gas. This doesn't make reference to the fact that some of the oxygen combines with the carbon electrodes to form carbon dioxide. Okay, right, that's your overview of the C4 topic. Hopefully that gives you enough to go through your notes and complete any of the lesson questions. Thanks very much.